Okay, so today is just going to give you with this video the rules for sketching rational functions. And these are called hyperbolas, the graphs of these. So consider rational function f of x equals p of x over q of x. And what we're going to do here is going to go over a strategy. This is for graphing by hand. Okay. Ultimately, if you have access to a graphing utility, graphing calculator, Desmos, or something like that, it's going to be a lot more time friendly for you to get a picture of these. But if you don't have access, you can still create a pretty decent sketch with just a normal scientific calculator to do some arithmetic on. So the first thing is you want to fully factor both p of x and q of x. So whatever that might entail, it might be GCF factoring, it might be AC method, it might be factored by grouping, it could be difference of cubes, sum of cubes, something like that. You never know. You have to do that first before anything else. Then you'll rewrite in factored form. And cancel any common factors. Cancel any common factors. Now, when you do that, you're going to make note of the factors that you canceled out, because these will be the location of holes, the point discontinuity, later on when you actually sketch the graph at the end of the process. So I'm going to put here holes occur at the zeros of the canceled factors. At this point, once you do these two things, you will have the most, I'll say here, the simplified form of f of x. Okay. Everything that we do from here on down the page, you need to make sure you have the simplified form of the function. All these rules that we're about to discuss are not going to hold unless you've canceled out common factors. So that has to happen. Now you can get into the characteristics. You're going to identify vertical asymptotes of the graph. You'll see I'll abbreviate it VA. Okay, and you identify the vertical asymptotes by looking at the zeros of q of x. Put here located at the zeros of q of x. So again, that's the denominator of your fraction. Now, the vertical asymptotes, they split the graph up into different pieces called branches. The number of branches that compose the hyperbola will be 1 greater than the number of vertical asymptotes. So, if we're just in general speaking right now, if you have 3 vertical asymptotes, that means you have 4 branches to your graph. If you have 1 vertical asymptote, that means you have 2 branches to your graph. So it's always 1 greater. So that's for vertical asymptotes. Next would be identify the horizontal asymptote. And I put the because you can't have more than one. And I'll abbreviate that once we do some problems later on with HA. This is a little bit more complicated to figure out. What you do is you have to do a comparison of the degree. If you remember the degree back when we did the chapter on polynomials is the greatest power in the expression. So you're comparing the degrees of the numerator and the denominator. And there's 3 possible outcomes here. The degree of p of x, the numerator, could be less than the degree of q of x, which is the denominator. The degrees could be equal. Or the degree of p of x could be greater than the degree of q of x. Now, in the first scenario, the degree of p of x less than the degree of q of x, y equals 0 is your horizontal asymptote. In other words, the x-axis. If the degrees are equal, you're going to have y equals a constant. Now that constant you find by dividing the leading coefficient of p of x. Divide that by the leading coefficient of q of x. And then the last case, if the degree of p of x is greater, then there is no horizontal asymptote. Now what I'm going to do here is I'm going to put a little star, because in this last case where it's none, you could have what they call an oblique asymptote. It's also called a slant asymptote. And we'll get to that in a later video. That's extra work for sure. I'm just going to put here, no, I'd said it, but I'm going to write it down. There can be, at most, 1 horizontal asymptote, and it bounds the end behavior of the function. So something you would have to get used to here, you haven't really seen anything like this, but the branches can actually cross over this horizontal asymptote in different styles, different ways. And so it serves really as a boundary as what's happening at the ends of the function. We studied end behaviors back in chapter 6. Next. There's more, but wait, there's more. Identify the x-intercepts. X-intercepts, if any. The x-intercepts, if you have any, they will occur at the zeros of p of x. Again, you have many different. If you have many different branches, you can have a lot of different x-intercepts happening. Identify the y-intercept. It will have a y-intercept, most likely. And that will be substitute x equals 0 into the function. Now remember, all these rules from here down are assuming that you have canceled out any common factors. In other words, using the simplified form of f of x. So if you do that, then it's on to the last step, the best step, which would be to create a table of values for each branch. I suggest that you use 3 points in each table. Three points minimum. You could do more if you want to be a real cowboy. But the 3 points that you pick, so I'll just draw an example here, right? You're picking numbers for x, okay? So you're placing numbers into this column, and then you would substitute those numbers into the simplified version of the function to find the outputs. You should pick them. I like to go a half of a unit away from each asymptote that's involved. I'll just put here if asymptotes are involved, vertical asymptotes, that is. Use half units. And you'll see when we do examples on this. So let's say I have a vertical asymptote at x equals 3, and I'm trying to figure out what's happening to the right of that. I might start with 3.5. If I was going to the left of 3, I would do 2.5. It's hard to sometimes see where the action is if you use integers only. So you have to be willing to use decimals. Again, you know, if you're doing this, at minimum, you should have a scientific calculator. And I'll just put here, this is the most time-consuming step. It's going to take a while. So you have to just have patience and you know, keep going at it. And then you're ready to graph it. So, I mean, these are all the rules. These are the rules I'm going to be referring to in the next video involving examples on this. So you really need to have all this down in your head to move on with this process. So see you in the next video.